If you build software today, you likely run the command npm install without a second thought. It is the absolute engine of modern development. We don't build complex applications from scratch anymore. We assemble them from millions of pre-written, open-source building blocks. In a standard software dependency network, downloading a single tool means that central node exponentially expands. It relies on 10 other tools, and those 10 rely on 100 more. To use one piece of code, you run code written by thousands of complete strangers. Package managers, the automated systems that fetch all this code for you, operate entirely on blind trust. They assume that if a package is listed in the registry, it is safe to execute on your machine. By optimizing for absolute convenience, we've created an interconnected surface where a single compromised block can poison millions of downstream users. That brings us to Axios. It is a foundational tool in the JavaScript ecosystem, relied on by nearly everyone to make HTTP requests. It handles over 100 million downloads every single week. In March 2026, two specific versions of Axios, 1.14.1 and 0.30.4, were published to the official registry. But these updates didn't come from the actual developers. They were weaponized payloads designed to exploit that massive web of developer trust. If your system pulled either version, it took exactly 1.1 seconds for a highly sophisticated remote access Trojan to embed itself into your operating system. The moment it had root access, the malware actively deleted its footprints. It scrubbed the installation files and reset the logs. Your standard system audit would show a perfectly healthy environment, while in the background, your AWS credentials and OpenAI API keys were quietly siphoned off to an external server. A developer could be sitting at their desk right now with a fully compromised machine, staring at a terminal that explicitly guarantees them everything is secure. To pull off an attack of this scale, the hackers didn't try to brute force the registry's corporate servers. They targeted a human being, specifically a lead open source maintainer named Jason. Jason is a security-conscious developer. He had multi-factor authentication enabled on all of his active accounts. Yet the attackers were still able to publish the malware using his exact digital identity. This animation illustrates the bypass. A modern login attempt hits that strict 2FA barrier, but older systems left a side door open. Attackers scraped a legacy access token from Jason's machine, a key that slips right past the modern authentication requirements. This legacy token gave the attackers full administrative control. They could bypass every standard check and push malicious updates directly to the registry, all under Jason's verified identity. It is a stark mechanical reality. The tightest cryptographic security in the world offers zero protection if a single forgotten credential is left active in a maintainer's digital footprint. The attackers changed 0 lines of actual Axios source code. They didn't rewrite a single function or hide a virus in the library itself. This editor view shows exactly what they did. Instead of injecting a virus, they targeted the package configuration file. They just inserted a single string of text, instructing Axios to require a brand new dependency called plain-crypto.js. On the surface, plain-crypto.js looks identical to a standard harmless math library. It easily passes static security scanners, and to a human reviewing the code, it just looks like a routine update to handle basic cryptography. But hidden inside this phantom package was a post-install script. This is a native, widely used developer feature that tells the package manager to automatically run specific setup commands the exact moment a download finishes. The attackers took the exact automation tools developers rely on to save time and turned that mechanical convenience into a direct, silent vector for infection. Let's trace the execution. A developer runs npm install. The post-install script triggers. It executes a heavily obfuscated file hidden deep inside the fake crypto library. The script checks the victim's operating system, then reaches out to an external command and control server. The server instantly fires a custom payload back, dropping a tailored remote access Trojan. Finally, the script immediately wipes its own files, covering its tracks. In just over a second, the attacker gains absolute dominance over the system, extracts your credentials, and scrubs the timeline so cleanly that you never realize you were attacked. If you discover this Trojan on your machine, simply highlighting the file and hitting delete accomplishes nothing. The perimeter is already breached. You have to initiate a scorched earth response. The entire machine must be treated as permanently hostile. Developers have to systematically hunt down and rotate every single API key, access token, and credential they have ever saved on that hard drive. This animation illustrates what security researchers call the nuclear fission effect. When an attacker steals credentials from a single developer, that node turns red. Those stolen keys are then used to unlock the 3 other projects that developer maintains, which in turn compromises the 9 projects relying on those. It is a chain reaction. The malware scrapes personal data specifically to harvest the access needed to poison the other projects you work on. Because infected developers are frequently the maintainers of entirely different software libraries, a single hacked machine can spread a compromise exponentially across the internet. Zooming out to the macro level, it exposes the fragility of our current software model. When a library like Axios is downloaded 100 million times a week, a single compromised maintainer becomes a single point of failure for thousands of downstream applications. The Axios hack reveals that until the industry addresses the flaw of inherited trust, the code we blindly rely on to build our tools will remain a primary target for systemic compromise.